Okay, YouTube people, so the installation of the DROPRO DRO on a Grizzly 4002 lathe. I took a bunch of videos yesterday, and I'm getting stymied by the batteries running out and things like that. I'll have to figure out how to manipulate the technology at my disposal, but let me show you what I did here. So if you look at the video that these guys provide on the DROPRO site, they're installing this DRO on a Grizzly 4003G gunsmith lathe. It's very similar in parts. The apron is the same, the cross slide is the same. It's got some additional appendages off on the side of the cross slide over here, where they've got a light and the coolant system. I don't have that. That actually frees up some space for me. But there's some slight differences between the apron on mine and theirs, in that I have less meat to drill into here. So what I learned yesterday is that even though this cross slide easily is long enough as it comes from the manufacturer to fit the entire length of the cross slide, I wound up having to cut it down. And the reason is because you screw it in on each side here. Of course, you've got to tap and drill and tap. And if you bring it out further here, you're going to wind up screwing into the gib adjustment. And so I had to pull it back on both sides by, roughly 7/8 of an inch in order to clear the gib adjustments. What that did was it made for an interesting scenario in that I've just about, and you see if I move the cross slide, let me take that. This is a something I'll tell you about in a second. If I move the cross slide all the way out, I actually have no space between the sensor, and it actually winds up hitting the sensor like that. Now that's the maximum travel, but still I don't have any clearance anymore there. All right, so just to give you a better view here as well. So this is the scale, the magnetic scale itself, and this is the sensor. I probably should have said that up front. If you look down here, you can see that. Let me put down my iPhone. I'm using the iPhone as a monitor, kind of, so I can see what you're seeing. Down here, and maybe I get the light on better too. So down here we've got the bracket that connects to the apron. Hello, kitty. And the pickup sensor is connected to this bracket. I wound up having to shave down the default bracket quite a bit, the one they sent. I wound up, I would say more than half of it came off on the mill yesterday. But it's mounted in, drilled and tapped with two actually what I wound up doing is I replaced their screws. They have M4 by 0.7s. Excuse me, they're not. They're M6 hex head bolts. I wound up replacing it with 1/4 by 20s because I have a lot of those laying around. Also, I didn't have a tap for the M6, so I went with the 1/4 by 20 taps I have. I have about 15 of those, or 150, how you want to look at it. So placed that in there, sensor on top, put the scale on. I tied down the sender wire, and if we head around to the back here, I haven't had a chance to mount that yet. Sender wire. I'm trying to figure out exactly how to position this. I'll either drill a hole down here in the chip pan, or I'll find a way out around the motor. That comes up here and to the display itself. So I mounted the display here on this this little arrangement I put to store things. I'm gonna have to probably find a better spot for many of these things here. And the display has to be grounded, so there's a ground strap that's just going into the body of the lathe itself. This is one of the screws for the chip guard. And today I'm going to put in the Z-axis. So let's see if you can see back here. So there's two connections, two good old DB9 connections, one for the X, one for the Y. Some other things, I guess you can upgrade the software in it. There's a USB, and then there's a bunch of closed off. I don't even know if there's anything behind there. But I guess if you get a mill version, 3-axis version, or even a 4-axis version, they've got some things back there that would be useful. And then there's the probe output, or input rather. So that's where we've got so far. Now another thing is that I had to machine down the guard, and let's there goes Sammy the cat. All right, so let's head back over here. So things to note, the tolerances on the positioning of these things are pretty darn tight. They seem to be loose when you watch the guy at the on the video, but the truth is they're pretty darn tight. Now it's not hard to do. Mounted the scale and just indicated it in with, you know, just an old start indicator. The actual pickup has got to be within 1.7, excuse me, 0.5. It's got to be within 0.5 millimeter of the face here. So this face of this reader has got to be within 0.5 millimeter of that surface. They give you this gauge. It fits in between the two rails there like that, and you can basically press the receiver head, the read head, right up against there, and then tighten that down. And then when you yank it out, you're in the right spot. So these things come with each scale. That's a plus. On the video, they show these things as being a piece of clear plastic, which you could never find. This is a much easier thing with a nice little finger hole in it. All right. The last thing I'll show you here is the guard for it. Now I've had, again, once again, I had to mill this thing down quite substantially. It's a piece of extruded aluminum. On the video itself, it looks like a piece of sheet metal, and I wondered how I'd cut it without distorting it. But it's a piece of aluminum extrusion, very easy to cut on a bandsaw or with a hacksaw. In my case, I just milled it and bollocksed it up a little bit on that corner there. But at the end of the day, it's going to get hit and abused quite a bit, because this is not exactly a kind surface when you're, you know, it'll be hit by chips and whatnot. So, and they also suggest that you bolt it in to the top of the scale itself. And there's two M4 by let's see, M4 by 0.7 tapped holes there. So now they provided some, I don't know, I've heard them called cheesehead screws, which in my case actually would have worked. They're a little long. I have buckets and buckets of random screws, so I found these little guys, and that works fine to hold that down. So that's held down. This is braced, and now the next thing I got to do is get the Z-axis up there and route it up here to the display. All right, I'm down here around the back of the lathe, and I've got the bracket that they provide for the Z-axis. Now, what they provide is a block that goes back here that would bolt in to basically as a plate protecting the cross-slide feed screw. In my case, what I've done is I had previously purchased for a project the accessory that allows for taper cutting, automatic taper cutting. That was bolted into here, and there is an additional feed screw provided, and an additional cross-slide travel dial that you could turn in the front. I liked, actually here it is right here, the handle and the dial on the upgraded cross slide for the taper I liked it a lot better than the stock taper, so I left it on. But that meant I had to use the original feed, the upgraded feed screw, which was slightly longer than the smaller feed screw, which meant I had to put this little device on and bolt it in that way. So short of that long story is I don't have any room to put this up here. If I could put that up here, well, if I could get it up about that high, as you see, I'd be down around here for the Z scale, which wouldn't be too bad. That would fit. I certainly want to avoid this open area. I wouldn't want anything to hit it from behind. I want it to be flush against this surface. So I believe what I'm going to have to do is take this bracket and cut it down. And so, as with everything else on this project, everything's custom, which is what makes it such a fun project, I suppose. I'm thinking right about there. So what I'm going to try to do is I'm going to try to mount it right under here. I'm going to drill and tap under here. And I'd like it to be, I'd like this piece right here. This is where you, the reed head gets mounted on top of that. So I'd like to bring that probably right about to there. Because with the reed head about there, then the Z-axis will be roughly here. And when I put the camera down, I'll take all those measurements. Again, reed head roughly where my index finger is, right there. And then the Z-axis would be right about there. And I'll put the camera down, I'll get the rulers, I'll measure that. Then I'm going to go to the mill, because that's the only device I have to really cut this. I'll probably cut it off, cut these grooves out, put 2 more grooves in, and mount it, bolt it in and mount it right underneath there. So that's the project for this Sunday morning. All right, what do they say? Measure twice. That way you only have to be surprised by the depth of your stupidity once. All right, so what I've done is I put the reed head on here. Everything I said before seems reasonable, but you know how these things go. You cut the metal and then you get there and things aren't what you expected. So let's just size it up. So if I was to mount this, drill or mill out 2 more grooves here and drill and tap, I'd have the reed head roughly there. Roughly there. Right, not roughly, but exactly there. Now the nice thing is if you tap mill out the grooves the right way, this also has quite a bit of adjustment ability in it. Then I could move it up and down an inch or so. But I think if the problem I'm having is that it really sort of looks like I could use these existing grooves if only this were shorter. And I really hate to shorten it that much, only to find that that's an inappropriate place. But you know, if I cut the tops off of that, it's just not going to seem as sound in installation with these things U-shaped and open, and this thing could just drop out. I don't think it would ever drop out. Actually, if it moves even a couple millimeters, it's not going to work anymore. But in any case, that's where we're at. So as you can see, that would not be such a bad place for the Z-axis scale, right about there. And all right, now the only question is, do I just cut this off here? Because this needs to be mounted under there. So do I cut it off roughly there and leave these open? Or do I cut this off here and put 2 new grooves in, and then it'll be up roughly that far, which also isn't such a bad place for it, to be perfectly honest. I just hate cutting this much off, but so far I've had to cut these things down significantly everywhere. All right. All right, back here behind the lathe again. You know, I've heard that the YouTube has bots that scan all the videos that are uploaded for copyrighted materials. So for instance, people have music playing in the background. Sometimes they've got radio stations, or they're playing, you know, their MP3s, or if they're old guys like me, CDs. I don't think anybody plays vinyl in the shop. At any rate, the YouTube people snag that, as well, I guess as well they should, but I can't imagine anybody's going to be watching a video of someone building a boat or working on a lathe just in order to hear Close to the Edge or some other copyrighted material. So at any rate, I'm remembering to turn off my music before I turn on the camera, because I know some of the guys that I like to watch have to do that frequently. I'm using, by the way, I use this Sonos. I have nothing to do with Sonos except I'm a happy customer, and the beauty of that is you listen to exactly what you want. I actually had Pandora on before this. I was listening to Close to the Edge, you know, Yes, and Spock's Beard, and Emerson, Lake and Palmer, and UK, and all those great progressive rock bands from the 90s. Who needs to hear that? You guys don't need to hear that. Anyway, so here's what I did. So I milled down this bracket. You know, there's something about that just doesn't sit right, the fact they're open on the top. Except I don't think I want to cut it down much further. I've got the reed head mounted on here, so what I want to do is just size this up. And if you can see in the dark, which I can't, that will go right there, and the reed head will be roughly here. And that's not such a bad spot for the Z-axis scale. It'll be flush along the bed of the lathe here. And the only thing is, well, let's see, the apron's not going to move much further than, certainly isn't going to come out to there. I mean, the bed, the ways end right there. Matter of fact, I can't get it any further out to the right than that. So I'm guessing that the scale, I'll probably cut it to end to go from here to here. I've got an 8-inch chuck in this bad boy. I mean, this lathe, the chuck and the DRO together, I think, are worth as much as the lathe itself. One day I'll sell this thing and get a nicer one. And in that case, what'll happen is I'll keep the chuck. The DRO will have to go with it because it'll be cut custom. All right, let's see where we go next. Thanks. All right, so I don't know what makes good video and what doesn't. I don't know if people necessarily need to see me drill and tap a hole here, but I'll show you what I did. So I held this guy up here, and I've got this nice, I don't forget where I got this. It's a eBay purchase. Center punch. It goes in holes of variety of different sizes. You just got to line it up correctly, and I just tapped it, and I put 2 punctures there. I'm going to drill and tap this for 1/4-20. I've got hundreds and hundreds of 1/4-20 screws and bolts and nuts of all sizes. I've got tens of these number 7 drills, and excuse me, lots of these 1/4-20 taps of all, you know, bottoming taps. And here's a nice tap for this here. The fluted spiral flute. I've got spiral tip. I've got, for all intent and purposes. So I'm going to drill and tap that, and you don't need to see me do that. You can go look at somebody who's got a lot more experience than me doing that. I'm going to drill and tap that probably 3/8 to 1/2 inch, and then I'll mount that up there. Okay. All right, I got the scale, and I'm just holding it. I'll probably get some sticky tape and stick it on there. But you can see how this is going to go. So the scale is quite a bit longer than the bed of my lathe. I had to buy the 8-inch by 40-inch kit in order to get what I need. And so I'm going to wind up having to cut off, looks like almost 8 inches or so off the end there. Maybe more like 10 inches off the end. And the other thing I'll make a point of noting here is that in order to get the cable to exit on the right-hand side, as you see there, or on the left-hand side, as you see it from the front, I've got to mount the reed head essentially upside down, as it were. And what I mean by that is, you can see on the end here, there are those marks, and that indicates the beginning of the scale. So not only the beginning of the scale, but whether or not it's upside down or right side up. You've got to match up those hash marks with the hash marks on the reed head. And in this case, the hash marks in the read head are upside down. So consequently, those hash marks are in the down position. Oh, maybe you can't see it next to my Sea Alaska coffee cup there, but I'll take a look when I put it together, and that'll be that. We're going to do this the same way we did it yesterday. So we just pull off. This is a number 3 hex wrench, 3 millimeter hex wrench. Pull off the end, and then this thing, this also should note we previously marked where we want to cut. So this guy here is about 24-30 seconds, which I suppose would be the same as the 3/8, right? And we want to, I marked it so that the end would come out at the end of the bed of the lathe where I can possibly put it without interfering with the chip guard. I also, the DROPRO guys have a worksheet that explains exactly what the min and max is for your cutting. We're way beyond the min, so we don't have to worry about that. And that was explained on their videos, and also did it yesterday for the X. So slide this guy out. And try not to bollocks it up on the way out. And put that somewhere safe. And then we're just simply going to cut it right there with the miter saw. Okay, let's see if I can get you out there to see the miter saw. Alright, I've got the camera. Actually, I've got the camera on one of these gooseneck mounts. I just pulled off, when the camera comes in a box, there's a mount on the box. Actually, it's a little plastic thing. It's a little bit unstable, but in fact, I could probably turn it into something stable. That's what I'm using. The gooseneck, essentially on the plastic that came with the camera box, and then it's right up on top there. So what I want to do here is, let's first of all see if the saw is going to clear my fence and my hole down. It will. And make sure we're in the right spot. I see where the laser says we're going to cut. You can't see the laser, but I can. I'm going to be a little bit conservative and leave a little bit extra on there, and we'll just see if that's too long. We're also cutting on the side without the hash marks. That's right, we are. Boy, it seems like such a crime to cut off so much of this expensive scale, but that's what's got to be done. All right, here we go. As happened yesterday, my saw doesn't travel enough, so I'm going to have to do a little manual jiggering here. I'm going to pull this out just a tad. And make sure it goes back in the same hole without bollocking it. It works. Sorry for the jiggling around. You guys are probably getting seasick. Gotta get a better way to do this in the long term. Let's see if I can get that. There we go. Got it. Right, so let's take a look. So there's the end. Hopefully that's in focus. That's nice and clean. All right, now we got to go back and tap those two holes. I think they're M3 by 0.5, and then we'll be able to put the end back in. Okay, I've drilled and tapped the end of the scale here so that it fits our lathe. And if I bring it back here to there, what you see pretty much fits right in the hash marks that I made. That's the longest it could be. It would never actually travel that far. There's no reason for it to get that far close to the chuck, and there's no way you can get to the end that far. Again, I had to buy the 8x40 kit, so I had to chop off a substantial amount of this scale here. They don't make a smaller one. And as I said, I'm not sure many people would feel it would be worth putting a DRO that's capable of measuring down to a micron on a lathe like this. If I ever do any work that requires a 1 micron resolution, that'll be an interesting day for me. I don't know if this particular machinery setup could even handle tolerances like that. So if you're a spec junkie, this sounds like a really great setup. And the main reason I got it is because it's impervious to coolant and chips, and I spew a lot of chips and coolant. So I wanted something that didn't fail in the middle of a job just because it's got some chips in it. Let's see, so got the scale here, got the reed head here. The next step will be I'll tape this on with some double-sided tape, make sure we got everything kosher, and then I'll come back for the setup and measurement. Alright, so I'm removing this other side of the sticky tape, double-sided tape. This is the stuff you use to affix things to your chuck. So I'm really hoping that it doesn't present too much of an issue. So of course you gotta be able to get that behind this thing. There we go, behind the reed head. And let's bring it out there, and I'm gonna just try to eyeball it for straightness. Right now I just want to kind of just get it to the point where I can, oh wow. So here's the other problem with the sticky tape. It's got to stick to something that isn't covered in grease. Oh, not working, eh? Alright, we need a plan B. Alright, sticky tape plan B was to wipe the side down with alcohol, get all the grease off, tape it on there again. So now what I've done is I've got it taped up there, and I'm just trying to, first of all, I'm lining it up with the reed head best I can there. Now there's a number of adjustments I can make to the reed head, so I'm not too worried about it right now. To within a couple millimeters, I can, as long as I'm within a couple millimeters, I can adjust it. So I'm here at, let's see, looks like I'm just reading I've got to read the scale backwards, but if I read the scale backwards, I'm like at 4 1/4 there. And here in the middle, a little bit worse than 4 1/4, a little bit more. And here 4 1/4. So I think that's just the parallax that makes it look like I have more than 4 1/4. So I'm at 4 1/4 all across. What I'm going to do now is do a center punch on both those sides, drill and tap those and get that in there, and then we'll adjust the reed head. But I'm just looking if we get closer in there to the reed head itself. Looks like that's a good spot for it. All right. Okay, so I've got the Z scale mounted, drilled and tapped M4 by 0.7s, and it's lining up pretty okay with where I've got the reed head right now. Now comes the tedium of running this back and forth and indicating it in more precisely. I also got to adjust the in and out so that it is 0.5 millimeters from that surface there. But in general, you can see the effect. So if I move it, you see how the head moves along the scale, etc., etc. So that's the Z scale. I won't bore you with the in and outs of the indicating in. So what I've got here is one of my good old interrapid vertical indicator, which It does not seem to be in contact at the moment. There we go. We were just at the max of the travel. And this may be a little touchy for this, but I'll set that to 0. Now the thing is, I'm not at the full extent of the scale, and I'm going to have to figure out how I'm going to handle that. But if we start cranking this way, you can see already it's getting higher and higher and higher. So we're going to lower that right off the bat. I mean, it's just way too high. Ooh, but that's the wrong way to do it. All right, hang on a sec. So the hard part here is, all right, I've got, what I did was I tightened down this side. I ran the indicator across, it was too high, lowered it on this side, and I lowered it just by tapping it. Now I'm going to try to run it. Of course, you got to have enough altitude and arm length to be able to run this while watching it. And so it looks like for at least that extent, just make sure this thing is still in some semblance of. Let me try that. All right, now it's too low. Okay, I got fooled because I was at the extent of my travel. All right, we'll keep going back and forth. I've got it to within 2 thousandths, half one, yeah, 2 thousandths, which I think for something of this nature is it better be okay, because I'm not going to try to get it any better than that. I mean, the side of the lathe is not exactly flat. As you can see, there's some voids behind this. I don't think that's a happy situation. But all that's supposed to happen is that reed head is supposed to be close enough and parallel enough to the magnet that's under here to read the changes in the magnetic field as it goes back and forth. It doesn't need any force to do the reading. It just needs to be precisely aligned, and the alignment needs to stick no matter what kind of vibration is going on in here. So the screw on this side and the screw on that side have got to be tight. This has all got to be tight, and the alignment's got to be set, and then it's got to stay there. There really is never going to be any force on that. And there's going to be a protector guard that prevents the chips from getting behind there anyway. So I think we're going to leave it like this for now. Okay, so the last step in the alignment is to insert this gauge, which is a piece of plastic. I've measured it with a micrometer. It's about 0.454 millimeters, which I guess is enough. And you insert that behind the reed head, and you want to push the reed head in so that there's enough force so that that moves along with you. In fact, it was moving along with me. I think I got some grease on it. So that it moves along with you when you move the reed head. There it's moving along because it hit that finger hole. But basically, I think we've got it. All right, so onward. Okay, hopefully nobody gets seasick here. What I'm going to show you is, this is the mount that I've been using. I got this gooseneck, and this bottom thing, this is just from the box that the camera came in. So yeah, it seems, you know, it's a pretty hard piece of phenolic plastic. I think I may back it up with some with a piece of aluminum or something and drill some holes in it and make it to mount in various places. Anyway, I'm putting you back on there. show you. What I did was machined the cover for the Z-axis scale, and I had to shorten that lower end, the end that's pointing downward, so that it fit. And I left on, they advised taking off this tang here. I left it on. I'm still going to mount it directly to the scale, and so I had to machine off a bit of the tang so that the screw would fit, because I'll show you. So this slides in here, and now that I got this thing indicated in, I am not going to remove it. So, all right, let's put the camera still here. Wonder if you can actually see anything from there. Don't know. All right, I'm just going to pop the screw in on this side here. And of course, it's a tight fit because it's right up against the bed, lathe bed there. And we got to get this. There we go. And then on this side, just going to do the same thing. Actually, I've never done this before on this side, so I don't know exactly how it's going to go. So you should always do these things before you video them, just like the famous cooking show preparation things. And I see a drop of blood on my screwdriver. Please don't get upset by that. The wife and I make a lot of things. In fact, we have nearly built or reframed a lot of our house. So let's go crooked. And we used to have a saying, which is that if you don't bleed on your project, you're not putting your heart into it. Ha 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 ha. Okay. There we go. There we go. So now we have the scale on, and it travels back and forth. It's protected by this nice piece of aluminum. It's indicated in. Next step is we'll hook it up to the just do a trial run and hook it up to the head and see if it works. Okay, so I've got the x-axis and the z-axis scales both connected. I've just got them. I'm going to have to relocate my coolant here, my lathe coolant, now that I've got a coolant system, and my whey oil and my machine oil. At any rate, that comes up here and it goes in via these two DB9 connectors to the head. I wonder if I will in my lifetime ever see the end of DB9 connectors. I mean, I've been using these things since I was knee-high to a grasshopper, and they just don't go away. They're about the oldest connection technology, well, other than the plug that goes into your wall for power. I think it's about the oldest connection technology that exists. All right, let's try it. Power switch is on the back, and it says what it is. I guess that's some kind of code for hello. And if yep, there we go. So here's moving the z-axis, and that's moving 1 inch, another inch, another inch, and then I move this one. This guy looks like he's on a different scale. That did not move 2 inches. The entire travel of this x-axis is only 6, so I think there's some calibration that needs to be done. After I route the wires and get it hooked up, I'll run the calibration. But there you go. It's hooked up, and I guess I have no excuse to not be more precise with my cuts on the lathe now. All right, so here it is, the lathe with the DRO. Looks not so much different than a lathe without the DRO, except for this guard here that you can see directly. Let's see, I'll go around the back and show you how I routed the wires. And as with most things, this is going to be when I think of something better, I'll move it. So turns out that when I put the chip card back in, there's a void here in which I can get quite a lot of slack. And in fact, I can run all the way down with the slack that I've got to the end of the travel, and it's fine. So that's good. These are shielded armored cable, grounded on the outside. The only thing I worried about doing it this way, let's see if we go around underneath. If you can see, they're coming up around the motor, and I do worry that the noise from the motor could possibly interfere with the reading. I think, though, the fact it's grounded everywhere. So we're grounded here by direct metal-to-metal contact into the chip guard, which is grounded to the lathe itself. This device here goes to the VFD, and that's grounded through the VFD. The motor's grounded through all its connections, so everything should be happily grounded together. In fact, I'll get the meter out and check that and make sure. We come up around the side here. I'm staying away from the business end of the motor, which is in there, and I've just kind of wire tied it and to this wood. At the end of the day, we can always move things around and find a better spot, but this will be functional for now. I'll put the coolant system back in, and then we'll be operational. So there you have it. And in fact, turn it on, and the next thing I'm going to do is calibrate it via the instructions. I'm sure it's not, oh, it's not plugged in. I'll calibrate it via the instructions. It's all not that exciting. It's going to be a trial and error learning process, I'm sure. So anyway, there we go. I'm Joe wearing an apron the wife made, and just finished up the DRO on the lathe. And if anybody got any questions or wants to know how to put a DROPRO DRO on your lathe, if you got a Grizzly 2002, or rather 4002 or 4003, I might be able to help you. See you later. Just a quickie. Just like the guy who's finished working on his car and has a handful of parts left, wonders where the heck was all this stuff supposed to go. Here are all the parts I've got left after installing the DRO, and I've just gone back and looked at the DROPRO's videos, and I kind of understand why I've got these left. These guys are provided to mount the Z-axis if your lathe bed isn't level enough or flat enough to provide a surface to push it up against. So you put these on, and then you mount the Z-axis scale on these guys, which would theoretically, I guess you can, if they've got some grub screws with it, somewhere one of these packs that enable you to fiddle with the orientation of this so that it's level. This guy would have gone on the the Z-axis up by the lead screw for the cross slide. I didn't use that. I just tapped directly into the cross slide. This would have gone into the thing holding the plate for the cross slide lead screw. So didn't use that either. All sorts of odds and ends. These are bits of the scales that I cut off. Actually, they're right. They cut quite nicely with that Diablo blade, the 10-inch Diablo blade that they recommend. Really nice cuts, as long as you go nice and slow. So I've got those pieces left, and here's some other pieces. As you could tell, I kind of inched up to the exact measurement rather than going for it all at once. So I made numerous cuts. I've got this guy, which is the piece of plastic you use to adjust the distance of the reed head from the magnets itself. Now that's good for, I suppose, in the future if I move the thing around. Could use that. Pieces of the stainless steel flashing that goes on the scale that you cut off. Right, those things are garbage. Numerous nice metric cap bolts that inevitably I'll use for something, who knows what, and some hold downs that I didn't use these. Now that looks like a lock washer for the display head, that I've got to put in, although I didn't think I needed one, because as it turns out they provided some castle bolts with that Teflon in them that lock into place. I'm not sure I'm really going to need that guy. I've got numerous other little, as they call them, these cheesehead screws, which they recommended using to screw the guards into the scales themselves. I didn't do it that way, so I've got a bunch of those. Printed out all the instructions from DROPRO's. Actually, once I printed out the instructions and set it up the way they suggested, all of the measurements come out correctly. I don't have a calibration issue. I've got their manuals, got this manual. All kinds of interesting measurements can be done and adjusted for tools, polar coordinates versus rectangular coordinates, that I'm not sure is too useful on a lathe, probably for the mill. And that's it. So that's all the stuff that was left over after I put this together. And I can see the battery just about dead, so I'll go back and put this video together. It'll sit on YouTube. Maybe somebody will watch it, maybe they won't. What's the difference? I had fun doing it. This was a really cool project, and I think the DROPRO's guys did a great job of explaining the best they could how to get it attached. I imagine, you know, there's as many different lathes as there are manufacturers and people in the store things, so they emphasize you got to be creative with this stuff. Yeah, creative. Well, I guess the bottom line is you're probably a machinist, hobbyist, or an actual machinist if you're buying their stuff. So manufacturing the correct part out of something like this is well within your reach and your means. If you think, though, that you're just going to slap this thing on, good luck. That ain't happening. I can't imagine what lathe these things were made for. There's probably some generic lathe somewhere that you could do it, but even the one that they show on their video requires some milling to these pieces. So at any rate, thanks very much if you watched it this far. I'm Joe. See you later. Bye.